Welcome to the Real Python Podcast. This is episode 131. Python 3.11 is here. Our regular guests, Gerarna Hjelle and Christopher Trudeau, return to talk about the new version. Gerarna wrote a series of preview articles earlier this year, and his annual piece was published on October 24th, titled Python 3.11, Cool New Features for You to Try. Christopher's video course posted the next day, covering the topics from the article with visual examples of Python 3.11 in action. Gerarna and Christopher collaborated to create code examples of the new features. We discussed better error messages, faster code execution, task and exception groups, typing features, and native TOML support. We dive into the updates and offer advice about ways to incorporate them into your projects. We also consider when you should start running Python 3.11. This episode is sponsored by DeepGram. DeepGram is the preferred speech-to-text API of Python developers. Get accurate transcripts from any audio with features for understanding. Try it by transcribing 200 hours free at deepgram.com/realpython. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. So joining me again, it seems like an annual event that we're having here with the newly annual release of Python, is Gerarna Hjelle.
Hey.
It's good to have you on the show again. And Christopher Trudeau, my common co-host here.
It's been a long time. I think it's been 3 days. Yeah.
Yeah, exactly. We're excited to talk about all the things that are coming in Python 3.11. Gerarna has actually been documenting a lot of these changes throughout the year at RealPython, which has been kind of an interesting change for sort of our publication schedule and let you kind of get a lot of your thoughts in, and with not only the betas, but also the pre-releases. Do you want to talk a little bit about that, Gerarna?
Right. Yeah. So this has been like an experiment we did because the earlier years we just kind of loaded everything into one article for the release. And we're kind of doing that this year as well. So we have the big Python 3.11 article, but then I've also done 3 Python previews, essentially, where we just focused on, mainly focused on one topic and then kind of threw in a little bit here and there. So we first did one, so this will kind of be a small spoiler on what we'll talk about for the rest of the show, I guess. But first we talked a little bit about the improved error messages in the first preview. The second one, we focused more on the new async features, the task groups, and exception groups. And then the last one was about the TOML support that's added. So all of those things we'll also cover now in the big article and then other stuff.
Yeah, and that should be up on the site. Everybody should be able to check it out. This is going to come out just a little bit after the release week. Some travel and other things involved in my life right now. Mm-hmm. So sorry for the minor delay, but keep the excitement going with the new release.
Yes.
So great. Do you want to start with some of the stuff that we're going to talk about? We have kind of like a little list that we were going to go back and forth with, but we were going to talk about initially one of the biggest changes, and Christopher and I have been talking about it back and forth for the last several months about the faster CPython project and kind of what's going on to speed up Python, not only in previous releases, but, especially here with 3.11.
Yes, I think 3.11 is kind of going to be a great release kind of for developer experience, essentially. So we'll have the improved error messages that we'll talk more about later, but it's also going to be the fastest Python yet. And this is part of a huge effort by what's called the Faster CPython project. And this kind of stems back to a post that I think is about 2 years old now, that Mark Shannon did, the Python mailing lists, where he said that I have ideas for how we can improve the speed of Python 5 times over several releases. It's a really ambitious plan, kind of got tagged on the Shannon plan. And he kind of laid out lots of ideas for how to improve the language. which is really impressive for a 30-year-old language that you can kind of come along with these thoughts.
Yeah.
But also together with this was kind of, okay, this is really ambitious, and to be able to do this, we need a lot of funding. For a while, it kind of was hanging out there and saying, yeah, are we able to do this? Should we focus on this? But then Microsoft stepped up, and they've been funding a team that then includes Mark Shannon. It got Guido out of retirement to work with him, and then several other people. And I'm slightly scared to try to list the people on the team because I don't have the full overview. But I know that Eric Snow has been on the team for more or less the whole time, and also a couple of other core developers like Brant Bucher and Irit Catriel at least has been there, and there might be a few others as well that kind of been working on this project now for at least the last year or so. It's been really exciting to see all the things they've been able to do, and they've also been able to contribute to things that are not purely performance. And then a lot of the other core developers also rallied around the project and helped out with different things. So it's really fun to see all the excitement around this, really. And for Python 3.11, we're seeing quite impressive results already, where the speed up, I guess the proper answer is that it depends how much faster your code will be.
Yeah, what you're doing, right?
Right. But I think on average, on benchmarks, it's about 25%. Some certain codes, type of code, more like 60% speed up, others less. So it looks really exciting. And one of the cool things is that this will kind of happen without us as developers needing to do anything except upgrade to Python 3.11. It kind of doesn't rely on any code changes. It's just Python gets faster.
Yeah, it's really kind of cool. Like, I've been paying attention to this for a while now, and I did talk about some of these interesting changes that are part of the Faster CPython project. And one of them is this idea of sort of almost like JIT, like, just-in-time compiling type of stuff for code that seems like it sort of repeats. And we've talked about it a little bit on the show, but I had a chance to talk to Pablo Galindo Salgado about it, and causing him a bit of stress in releasing it, and lots of kind of interesting, if you will, code paths that things kind of traveled that they haven't before, and having to set up a whole new sort of testing regimen to think about that, which has been very interesting. But do you want to talk a little bit about that adaptive interpreter?
Right. So this, I guess, is the only big speed up feature that has its own PEP that kind of at least describes it. And I guess we should also just point out here that all the things we're talking about in terms of performance happens on the CPython interpreter.
Yeah.
And kind of the whole Python 3.11, it is the CPython 3.11 release, although other interpreters like PyPy do tend to keep up with things that are happening there. But I guess the speedups are kind of changing the architecture to some effect on CPython. Yeah, so the specialized adaptive interpreter, and the idea here is that, and I guess we need to be a little bit technical and kind of say that Python, to some extent, is compiled. Well, it kind of runs in an interpreter, but it's not the Python code that we write that runs. It's something called bytecode, which is a much more lower level language. So typically, if you have a statement in Python, it's maybe 3, 4, 5 instructions of bytecode that it's kind of split into. And one of these bytecode could be something like a binary operator, say addition or multiplication or things like this. And what the specializing adaptive interpreter does is that it kind of just keeps monitoring these bytecodes so that they're kind of tagged with the counter. And then when a certain code has been, or a certain instruction has been called several times, it's able to switch to a specialized instruction. So if it's kind of seen that, okay, this particular multiplication instruction has been called, I think the magic number is 8, at least in this implementation. So 8 times with floats, so float times float, then it will specialize the instruction so that it's, instead of your general multiplication that you have in Python, it will try to do a fast multiplication of floats. And then it kind of has the fallback so that if you that ninth time happen to multiply an integer, everything will still work, but it will kind of then fall back to the slightly slower one. So for the happy path, essentially, where you keep using the same data types, then this will speed up things quite a lot, actually. So it is definitely noticeable if you kind of do some benchmarks on it. So yeah, that's the main idea, essentially, just that it's able to detect at runtime that this operation keeps happening with these particular things where we know that we can do stuff faster than the general operation.
Yeah, I'm glad you brought up the idea that this is also just one of the things that's kind of under the hood that they're trying inside of the Faster CPython project. And I also like that you mentioned the fact that there's sort of funding behind it, because that's one of the things that has a little bit been missing in the development of it, and the fact that Microsoft's setting it up. And again, I'm not even sure the size of the team. I know that they were hiring somebody to kind of help manage the people and some of the stuff going forward. I saw job postings from Guido earlier in the year about that. So, but yeah, great to see the fruits of it this year.
Right. Yeah, I think the funding part has been really important to just get started on such a big rewrite of the internals, right? That they have changed a lot of how the bytecode works and things like this, which would be really hard to do just on a volunteer basis.
Yeah, totally. So speaking about other performance stuff, do you want to dive in here, Christopher?
Well, sure. And just to add on to what was just sort of talked about there as well, as the 312, which is coming, we spoke about in the last podcast. One of the things they're going to be doing is taking those bytecode pieces and shrinking them into little micro bytecodes. So this is the adaptive interpreter is the first step towards a bunch of things that they're going to be doing with that underlying bytecode to try and get a more performance boost out of it. So it keeps going.
Yeah, nice.
This isn't the only speed stuff that they've touched this time around. I'm going to talk about a few of them. The first one is what's called a zero-cost exception. In Python 3.10, there's a bit of overhead code for any function that has a try except block inside of it. And that overhead includes a chunk of memory allocated to the function, as well as some custom code for managing the exception. The idea behind zero-cost exceptions is one that they've been borrowed, stolen, whatever you want to call it, from Java and C++. So what's happening now instead is the compiler is going to generate a jump table for each try-except block, which is just a list of all the places to go with the code that handles the exception. So if an exception happens, you just go and jump to that other handling area. And the impact of this is that there's almost no cost to the code if there's no exception. So obviously you have to do code when the exception triggers, but if there isn't one, then there's almost zero cost, hence the name zero cost exceptions. So if you're using your sort of try except blocks with the try for your happy path and the exceptions for failures, the majority cases, hopefully for you, aren't failures. And so this should improve the speed of your code. And a side effect of this centralized jump table is that block of memory that I mentioned at the top that's normally associated with these function frames goes away. And that means your function header is a little smaller, and a little smaller could mean a little faster or more likely to fit it into a cache. So there's also, in addition to the direct impact of the exception handling, there's also a side effect of possible speed up for smaller functions as well.
That's great.
And then the next one that they worked on is in the interpreter's startup process. So you may have noticed that after you've run your code for the first time, there's a directory called Dunder PyCache, so _PyCache. These directories store the compiled bytecode of your Python. So this means that if you run it a second time, it can skip the compilation step. It's essentially caching that compiled thing. And when you run your code, what Python's doing is it reads that cache, it unmarshals the objects that are inside, so taking them from the disk format and putting them into memory format. Then it allocates the objects in the code onto the memory heap, and then it evaluates the code. So Python already had a feature inside of the import modules called freezing, which is where a bunch of stuff is grouped together and pre-allocated. And this essentially takes those first three steps that I was talking about and combines them into one thing on the disk. So the stuff that's on the disk more or less kind of gets directly loaded into memory, allowing you to skip those first three steps. The performance improvement here is they've decided to freeze more of the key core modules, and this is resulting in a 10 to 15% performance improvement on script loading times. And that can actually be pretty significant, especially for short scripts, because with short scripts, often a significant percentage of the runtime is actually that boot up part. So if you can get 10 or 15% performance improvement on something that's 50 to 80% of your code, you're getting a 10 or 15% performance improvement on your code essentially for free.
Nice.
And then the last one is sort of a grab bag of a whole bunch of different things. So the way function memory frames are created has been improved. They've made recursion more efficient. Code that converts ASCII into Unicode used to be a varying length feature, and now it's dependent on the length of the thing that's being converted. So it's order n.
Okay.
Com and perm functions inside of the math module were rewritten to improve their performance, and somebody went and tweaked some of the regular expression stuff for speedups as well. So between some of the stuff Garan was talking about and all this stuff I was talking about, this is where you're getting the 1.22 times speed up on the standard benchmarks.
That's great. Yeah, a whole bunch of stuff in there that you can tell already that it's going to depend on the type of code that you run. But it sounds like everything from just running scripts to running larger applications are going to see that change there. So that's good. Python developers from companies like NASA, Volley, and Spotify chose DeepGram's speech-to-text API for accurate, usable transcripts to power their voice bots, podcast analytics, and video platforms. DeepGram automatically transcribes any audio with understanding features like summarization, topic detection, and language detection, so you can do more with your voice data. Get an API key and transcribe your first 200 hours for free at deepgram.com/realpython. All right, so then one of the things that they've been doing a lot over the last couple revisions have been showing you better versions or updated versions of when your code crashes, these messages, these tracebacks coming back to you. So do you want to talk a little bit more about these new improvements for tracebacks in 3.11, Garana?
Yeah, so for Python 3.10, there was a lot of updates to the error messages themselves. This time they're updating instead how the traceback is shown. So that's kind of the thing showing all the error messages. So this will kind of help with any kind of error that we're getting in Python 3.11. And this thing is probably something that is better to see on screen than to hear on a podcast.
Yeah.
But essentially the whole traceback is annotated with small squiggly lines here and there. And these little symbols are just pointing out this is the important part of the traceback. So when you typically get a traceback, it's just a bunch of text and things, and it kind of takes some time before you're comfortable figuring out which part should I really look at and which part is more if I need to dig in to things. But with these squiggly lines, it really pops out at you that, okay, this is the part of the line where something happened. So for a concrete example, if you just do something like you have code that divides by some number, and if that numbers happen to be 0, then you get a 0 division error. And in the squiggly line, it will then distinctly just underline the one or the something divided by numbers so that you can immediately see that, okay, this is what's happening. So I feel just by this, just looking at these messages, I can much quicker just see what is actually the problem.
Yeah, definitely.
And then it becomes really useful if you have these complicated expressions where you maybe have several things connected. So if you kind of do a nested lookup in a dictionary, for instance, you'll kind of have a dictionary, then you look up some key, and then another key, and then another key. And if you then get a key error, then in 3.10 you kind of may not be completely sure what is the key that I'm actually messing up here. But with these squiggly lines, they will actually point you to that exact correct key that is missing. So you'll immediately see that, okay, it's the second nested key that's the problem. So yeah, I think that this is just going to be a great boost to, especially the debugging, of course. It's kind of when we see the error messages.
Yeah.
Just looking at these things recently with getting my errors in Python 3.11 has kind of been a joy. I've been really enjoying them. So I think this has been a great effort.
Let's make some more errors so we can see these cool
Exactly.
ASCII. I feel like they hired somebody who does ASCII art, because it's like they're doing a lot with the caret symbol to kind of like point, like,
Right.
hey, here, and then the tilde or enya or whatever that symbol is called officially, the squiggles.
Right.
And they're just kind of doing more and more with it. And it actually leads into what Christopher's going to talk about when I went through his video course, kind of looking at it, the way the exception groups are handled are much prettier also. So yeah, as you look at traceback, sometimes it's like this big glob of text that you kind of read from the bottom up, but now it's going to be like highlighted almost and pointing at stuff and giving you a much better clue, which I think is awesome. It's great that the PEG parsers let us do that.
Yeah, and the example in your article that I really, really liked was when you've got multiple calls to the same function call in the same line.
Right.
So if you've got 2 or 3 functions inside, say, a comprehension, or you've got 2 or 3 functions nested in another function or something along those lines, historically, when that goes pop, you just know, oh, there's a failure in that function, but not which call to it, because it's all in the same place.
Yeah.
This one, it gets underlined. So it's like, oh, it's my third one that's causing the problem, which makes it way easier to trace the issue. So it can, there are certain cases where this can make a big difference visually.
I guess just to kind of round this out, I should just mention, so the way this is handled is that they actually had to add some information to the code objects to be able to actually point out where in the line this is happening. So that means that there is some extra information kind of stored in the bytecodes than before. So it does take up a little bit more memory. It's fairly small, but it is noticeable. So if there are someone where you really need, if you're in a setting where you really need to optimize these things, it is actually possible to turn off these nicer tracebacks. So
you'd run your code with like a flag of sorts?
Yes, I don't remember the flag off.
That's okay.
Top of my head, but yeah, there's the setting essentially.
But it's a possibility. Interesting.
Exactly.
Okay. All right. Awesome. So, Christopher, you want to dive into how they've updated the exception groups?
Yep. So there's 2 new features connected to exceptions. One is notes and the other is groups. I'll start with notes.
Okay.
It's a small thing, but it's kind of handy. And essentially what they've done is added an attribute to exception objects that stores a little message called a note. And the idea is if you catch an exception and you want to add some information before re-raising it, you can call add note on the exception as a method. And the exception can hold more than one note, and you can see what notes there are inside of a Dunder Notes attribute. So if you're not catching it, if it still results in a stack trace, then the notes are printed out just after the main message that's associated with it. So this allows you to annotate more information, and I don't mean that in the type hinting way, annotate more information to the exception and give more information to your users when something goes wrong. So it's a neat little thing. It's not earth-shattering, but it's anything where you can tell your users, give your users a little better hint, or yourself as a developer is always a good thing.
That's a hard one for you to like come up with, like, what should this say if you're just creating an example as like an article or a video creator.
Yeah, so I would think like the typical use case is if you've got, like, say you're catching an exception from a library somewhere and you've got more information that, so rather than the generic, I couldn't open this file, maybe you know something about why you couldn't open the file. It isn't there, or you gave me a directory instead, or something along those lines. You could add that to the note and that would automatically get spit out on the error. So
yeah, nice.
It needs the programmer to have the context to give you that information, but it gives you the ability to do that. Historically, you probably would have put like a log message or a print and then re-raise the exception. This is kind of associating it with the exception, which tends to mean it'll automatically get caught in your loggers and whatever. So it saves you a step for this kind of information that you might have been doing before.
Cool.
The bigger new feature is something called exception groups. So if you've ever had an exception generated during your exception handling, this feature might be for you. So there are a couple different situations where multiple exceptions can be generated, or when an exception happens inside of an exception. And it could be clearer if this was handled as a single unit. And that's the idea behind exception groups, is it allows you to group exceptions together. So you create an exception group object, you pass it in a name for the group and a list of of the exceptions that are in the group. And then you can raise this group just like you would an exception. So for the most part, once you've got this object, you can treat it kind of like an exception. It's not a big deal. And then the stack trace, and this is what you were hinting at earlier, when it gets spit out, there's these nice little ASCII art borders around it showing which the different exceptions are in the groups. And there's some information about, this is group 1 and this is group 2. And so it gives you, I find it personally way easier to read than the whole, while processing your exception, another exception happened. It cleans it up nicely.
Yeah.
And then in addition to the new class of objects, the language has a new piece of syntax, and that is except star. This works just like the except keyword in a try except block, but you put a star after the word except. And when you use this new syntax, you're able to catch an exception that's inside of an exception group. So say I had a try except block with except star value error as group is my line. And that's my catch clause, right? So if an exception group is raised that has a value error inside of it, then the except star value error would catch it. And then that block itself would get a exception group passed in. So you don't get the value error like you would normally do in a regular except value error. You get a group containing the value error. And they did this on purpose so that if there's more than one value error, you will get all of them. So it allows you to catch multiples inside of the group. And you can do this same kind of operation by hand if you've got an instance of an exception group. So there's a method that they've added called split, and that returns a new group containing whatever you split on. So back to, I've got an exception group. I've got, say, 2 value errors and a type error in it. I can call split value error, and it will give me back 2 groups, one with the value errors in it and the other with whatever else that wasn't a value error. So it's this kind of filtering concept that's both in the block and on a method on the groups itself. And when the baton gets passed back to me, I'll tell you about a new feature in Async.io that uses this new syntax. So they're already taking advantage of it later on. Spoiler alert.
It's neat. There's been a lot of work happening with exceptions generally. Just you started off talking about the zero cost exceptions and working there, and I definitely can see some expertise of different individuals kind of being used across the release. So that it's kind of neat to kind of watch.
Yeah, and I love the steal from other languages, right? Because there's nothing like watching how somebody else does it, and if it's working or not working, and then steal the good ideas and don't steal the bad ideas. So I'm all for watching what other languages are doing.
Yeah. So every year we seem to talk a little bit more about type hints inside of Python. And Garana, you want to talk about some of the ones here for 3.11?
Sure. Yes, as you say, the story's kind of been at every release. There's a couple of new typing things coming, and it seems like every year I think that now it's complete, we have covered everything. And then there's even more things coming next year. So I think this year there's 5 typing related PEPs that are kind of coming in Python 3.11, which I think is a record. Can't remember I've seen that many before.
Yeah.
Now, one interesting to some extent thing with type hints and the version. So these are type hints hint features coming in Python 3.11, is that a lot of them, they're able to kind of backport to earlier versions.
Okay.
Partly through the typing extensions module. So a couple of these things we'll talk about will actually work in Python 3.10 and maybe even earlier. But then at the same time, some of these things won't work even if you're on Python 3.11 because they're not implemented in the type checkers yet. So it kind of needs both the language support and it needs the type checker support. So actually, which things are working in which setups? Usually just a little bit of patience and things will start working, but it's not completely trivial to say when things are working.
Yeah.
That said, so the big things, so the things that have their PEPs, I'll kind of quickly just rush through them.
Okay.
And then dive into a little bit more detail on a few of them. One of them is just called variadic generics. The idea here is that a generic in terms of typing is that you have a type that's parameterized by another type. So a typical example would be that you have a list of strings or a list of integers. So both of them are lists, but they're parameterized by strings and integers. So as in this case, the list is kind of the generic. The variadic part that's kind of coming is that you can have things that are parameterized by an sort of like an unknown number or a variational number of different types. So to have a concrete example here, we may have a tuple. Maybe we have a pair, so we have two things. So we have a tuple of, say, string and int. In that case, it's easy to parameterize this as a generic. We need to use something called type variables, but essentially we just say that, okay, the first thing has a type, the second thing has a type. But if we have a tuple and we don't know how many elements the tuple will have, then we can't really type in that properly as a generic. So if we don't really know the types, we just know it's a tuple of n things. So that's where kind of your variadic generics come in, and they added something they call a type var tuple, which is then a type variable that can hold a variadic number of other types, essentially. So it's again something that's probably easier to see than to hear.
Yeah, your article covers it pretty well. Yeah,
yeah. So we have a couple of articles for this, and the main kind of motivational use case for this has been to be able to add type hints to arrays, typically NumPy arrays of different shape. So you kind of want to say that, okay, I have an n-dimensional array where this n may vary. So it could be a one-dimensional vector or a two-dimensional matrix and things like this. So that's where you kind of get the variadic thing, and then be able to then actually add annotations on those kind of arrays. So that's probably one of the bigger things, but at the same time, it's also, I think at the moment, still not properly supported by at least not all type checkers. So it's one of the things we still need to wait a little bit on. Then a related thing in the sense that it's currently typically handled by these type variables is something they call the self-type. And this is something that sounds like more or less a trivial problem. So if you're creating a class and you have a method which returns an instance of your class, then you want to have the return value should then just be I return myself. And that's exactly what this self-type will be able to do. But before we had self, we could try to kind of say, okay, I have a point class, and this method returns point. But that wouldn't work because point isn't defined yet. So then there were things like you could add quotes around point, and then the type checkers will be able to figure it out. But this wasn't quite enough either, because if you would then start to do subclasses of your point, then the annotation that it returns a point is no longer true. It returns the subclass of point and so on. So there's a lot of kind of subtleties in how to actually annotate these kind of return values. And that's now all kind of wrapped into this new self-type that just handles everything. So what's kind of been something you almost need to really understand the whole type system to be able to figure out how to annotate, you can now just do from typing import self and then annotate with this self thing. A couple of the other smaller features is one that's called, you can tag something as an arbitrary literal string type. And the idea here is that you have a string that you really want to make sure is a literal string. So it's something that's kind of spelled out with quotes. Typically, this would be strings that you'll use in an unsafe place, like, for instance, in a database query or things like this.
Okay.
And you want to just make sure that it's not tampered with. So it doesn't contain information that comes from, say, a user entering a value, or you're parsing from some unsafe source. So type checkers, the idea is that type checkers will be able to see, to check that literal string types, that they are actual literal strings, or at least put together by several literal strings, and so on. So it will kind of just help a little bit with security. And then two others. So one is called, it has the descriptive name marking individual type ticket items as required or potentially missing. And this harkens back, I think it was in 3.8 that introduced the typed dict type, which is then a way to annotate dictionaries with kind of which fields should be in a dictionary. Okay. And this new PEP 655, it's called, is essentially just adding a little bit of features on top of this so that you can more flexibly say that this particular field is required and so on. And the final one is one called data class transforms. And this one is just something you can add to classes that look like data classes, essentially. So it's kind of just to help out maybe more help your IDEs and editors than actual do the typing checks, in that you're just marking this class behaves similar to how the data class behaves in terms of that it kind of lists fields and so on.
Okay.
Yeah, a lot of different small little features that are kind of rounding out, I guess, that they're small, mostly small niche cases.
Yeah, it's not like sharp edges that have been existing in the typing
Right.
and trying to figure out kind of ways to deal with it. The self-type one is the one that I've heard the most about.
Yeah.
And I think the other ones are, again, just sort of helping kind of, I don't know if it's mature the way to think of it, like the way that we're growing into using more of these kinds of situations. And, but I I think there's always going to be growing pains of adding, typing to a dynamic language. So these are definitely trying to cover much more of these things.
Yeah, no, and I think the way they've done it, where they kind of started with a fairly solid system back in Python 3.5, I think, and then kind of just iterating on top of it, I think that's been working fairly okay, at least.
Yeah, gradual.
Yeah, I guess that technically means the way you apply it to your code, but I guess also they've been gradually introducing the time system.
I'm expanding the definition.
Yeah,
right.
I'll definitely buy into that.
For this week's video course spotlight, I want to remind you that Christopher Trudeau has created a video course all about this week's topic. In the video course, you'll learn about the new features and improvements in Python 3.11, like better error messages with more informative tracebacks, faster code execution due to many efforts in the Faster CPython project, task groups that simplify working with asynchronous code, several new typing features improving Python's static typing support, native TOML support for working with configuration files, and dives into many of the additional features we cover in this week's show. This latest version of Python is faster and more user-friendly. After 17 months of development, it's now ready for you to use in your projects. Like all the video courses on RealPython, the course is broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All of the course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. All right, Christy, we're going to talk a little bit more about kind of the ways that these exception groups were being used in async.
Yeah, so if you're familiar with async.io and the gather command, I can summarize the next feature in a single sentence. There is now a context manager-based mechanism that does the same thing as gather called a task group. If that sounded like gibberish, then I'll give you a little more background. So the async.io library was added in Python 3.4. Seems like that wasn't that long ago, but it's been around a while. And this is an alternate way of doing IO-bound parallelism, which means doing two things at once if your code is likely to be waiting on input for a while. Between Python 3.4 and 3.7, the library was solidified, and it eventually resulted in two new keywords introduced, which were async and await. So the library is built around the idea of what's called a coroutine, and this is a coding pattern for creating multi-threaded applications. If you want to build some parallel code, you write some functions using the async keyword. You then build a series of tasks based on calling these functions and then fire them off together. And the system takes care of the fact that they're parallelized. And at some point, you need to say, okay, I'm done with this asynchronous stuff, and I need to get back to synchronous. And before 3.11, you did that with a gather statement. As an example, in Python 3.10, you would put the constructed coroutines typically into a list, and then you would pass that list as an argument into gather, and then that's where the code would wait until all the tasks were done. So Python 3.11 has simplified this a bit, and instead of using a list and calling gather, you create a task group as a context manager. So this is an actual object task group, and inside of that context manager block, you use the manager instance to create the tasks themselves. The gather step happens automatically, essentially by being part of that context manager. So the resulting code, for at least for me, I find is easier to read. It typically takes only 1 or 2 fewer lines. It's not like it's a huge savings.
Yeah, it's a touch more succinct.
Yeah, it's succinct, and you don't need the list or the gather. So you essentially you're looking at a block that says task group, and these are my tasks. So it translates, at least for myself. I can't speak for the rest of you, but it matches my mental model better than the extra step you had to take with gather. So it just feels cleaner to me. And then, as I mentioned before, or hinted at before, the task group takes advantage of those new exception group ideas as well. So if something goes wrong in one of your coroutines, the exceptions can be grouped. And if you're running multiple things at a time and multiple things go wrong, then those exceptions might be grouped together. And this also provides a whole bunch of interesting stuff under the hood about how the tasks get shut down if one of them fails properly, because there's more context information going on in the background here.
Nice.
There's a article in the October 11th issue of PyCoders from Guido actually talking about the trickiness of how semaphores had to work to get the task group to work properly. And we'll link to that in case you want to dive deeper into this stuff.
Yeah, sounds good.
Guess we can also just note that some of these ideas have been around in other libraries for a long time, like Trio and Curio.
Okay.
But they've struggled with the implementation, partly because we didn't have the exception group concept in the language. So in those libraries, they kind of created their own ways of handling the multiple error things. So task groups were actually, I think, planned for Python 3.8 or something, but they kind of stopped on, we don't know how to deal with the multiple error part. So it kind of had to wait for the exception groups to be implemented before they could finally add task groups properly to the language.
That's good. It's nice to see, the architecture allowing that to happen. So the next one you're going to talk about, Garana, you wrote kind of a much longer piece already about at RealPython, kind of diving into it, talking about the TOML.
Right. Yeah. So TOML is a configuration format, and it's short for just Tom's Obvious Minimal Language. So the creator kind of named it after himself. Yeah. So TOML is short for Tom's Obvious Minimal Language, and it's been around now for about 10 years, and it's gotten more and more popular with different languages. So it's used in Rust, for instance, for the cargo files and things like this. In Python, it was picked up, it's probably 5 years ago now, in a PEP that was kind of talking about how can we specify packaging or package metadata. And they decided that we want to use a file that we call pyproject.toml, and as the name says, it used the TOML format.
It's more that borrowing from other languages there, kind of looking
Right.
at what Rust was doing in some ways, yeah.
Exactly. So since then, the TOML file format has kind of played a role within the Python community, and there's been several TOML parsers, but all of them has kind of been third-party parsers. So nothing that's been within the Python standard library. So that's meant that important tools like pip needed to kind of just rely on these kind of third-party libraries. So they would kind of vendor them into pip, but still it was kind of an extra step. And for some time you didn't really know how things were maintained, and there were some parsers that kind of came and went. So it's kind of been a situation where you need to kind of follow up with what different volunteers in different communities have been doing. So now that both the, say, support or the use of TOML within the Python community, we kind of realized, okay, this is the way we're doing things. And the TOML format itself is kind of settled on a version 1 now in early 2021, I think. That they felt that, okay, now is the time to actually bring TOML into the standard library. So in Python 3.11, there is a module now called TOML-lib, which can then do TOML parsing. And it's it's kind of modeled similar to how you would read things like JSON, so that you just import the TOML-lib, and then there's a load and a load s function to either load directly from a file object, or you can load from a string that then contains a TOML document. And everything will then be loaded into memory and parsed into a dictionary in Python. This dictionary will then be nested and potentially contain other dictionaries or other kind of values that kind of come from the TOML format. Everything is built on top of a third-party library called Tomly, which is also one of the newer parsers. But one of its strengths is that the whole code base is fairly simple, so it was kind of easy to maintain. And they were able to more or less bring it in as is, so that Tomly now works as a backport. So if you need to kind of support TOML on Python 3.11, but also older, you can just fall back to use Tomly on the older versions, and then TOML-lib on the newest version. So they kind of play together really nicely.
That's great.
Yeah, so it's fairly straightforward to kind of start using. And personally, I've been using TOML files for other configuration as well. I tend to like it much more than say YAML or JSON for configuration when it's things that I want to just spell out myself, because I think find it easier to handwrite the TOML stuff.
It's easier for you to write as well as to parse as you're looking at it?
Yeah, I find it easier. It doesn't rely on the sometimes subtle indentation that you have in YAML, especially if you get stuff very, very much nested. It can be hard to keep track. And these things I find are more explicitly spelled out in TOML. It kind of, instead of relying on indentation, it actually uses, it keeps repeating where you are in the tree, so to speak. So it's not dry in the sense that it definitely does repeat itself, but it also means that it's quite easy to kind of pick up the nesting part of it.
Looks like it really ignores white space.
Yeah.
Okay.
Which, as Python programmers, we should all be very, very careful about clapping for, because
yeah, that's different. Yeah.
Yeah. No, it's good when we do it, and it's also good when others are not doing it for some reason.
Yes.
Interesting. All right. This one I was kind of excited about when I watched your video course, Christopher, with the date parsing. Definitely date parsing is advanced a lot over a couple versions, and you talked about dates quite a bit, and time zones, I think was that 2 versions ago?
It's been a while, yes. And I promise not to judge you for being excited about date parsing, but
hey, anything to make it work properly.
There is that. So there's an ISO standard, which is 8601 for the date and time format, which is year, month, day, time. And if for our European listeners who are scratching their head going, but yes, of course, that's the way it's supposed to be. Well, unfortunately, the rest of the world isn't as advanced as you are. And
especially people like me.
Yes. Yeah. Oh, yeah. We'll come back to my comment about the Americans at the end. Yeah. So the date time module has always parsed these fine, but Python's only ever partially implemented the ISO standard. So it handled year, month, day, and time, but couldn't handle week numbers or times without a colon separator, or the trailing Zulu time zone indicator, which are all part of the spec. They essentially just ignored those parts of the spec. In the Python 3.11, the date time module is now much more compliant with the spec. So it's always been able to parse, say, 2022 10-03 for October 3rd, but now it can also parse 2022 W40-1, which, although that sounds like a motor oil, is actually short for week 40, day 1, which is also October 3rd. So I'm sure this is helpful to someone somewhere, and it's great that the code now more closely follows the spec. I've never seen week format in practice, but I live in Canada, and we're too busy fighting whether the month or the day goes first because of our neighbors to the south. So maybe this is
I've seen Gerarna use it, actually.
Okay, there you go. So maybe, I was about to say maybe it's more common in Europe, and but it's always good to partially implementing a spec is always problematic, because it's the kind of thing that bites somebody, because they think, oh, it says it does it, and then it turns out it doesn't do your case.
Right.
So it's always good when new things like this are added.
It's not quite Julian. Julian's when it's like the actual count of days. Is that right?
Right. Yeah.
I don't know. I'm trying to remember. I had one of those situations where I had dates in a really wacky format, and I'm like,
Yeah, that's, I think in astronomy, they use the Julian dates, which is, as you say, count of days since, I think it's 4,700 something before Christ or something.
Yeah.
So it's a huge number. In Norway, a lot of societal dates tend to use weeks, especially in school and places like this. So I'm kind of exposed to it here, at least.
Oh.
Yeah, I've been seeing you kind of add it to some of our progression, and we are very weekly based as a, me as a podcaster, but also as a publisher. We put out stuff very much on specific weeks, so it kind of makes sense. But it's weird to think of like week 43 and go, where is that?
Right.
So,
for a little bit of entertainment, Google the 13-month calendar. There's a proposal out there on the internet. It solves so many problems. Every month has the same number of days, and there's like a carryover day, which adds an extra holiday to your year. I don't see the Earth ever getting around to adapting it. We'll start with trying to get the Americans to take on metric, and then we'll move to a more reasonable calendar. One thing at a time.
All right. Well, next one up is a little bit about, I guess, displaying, is it integers and floats as far as negative stuff?
Right. Yeah. No, so this is another, I guess, this is more of a weird technicality in how numbers are represented. So it's, there's a concept of a negative zero, which as a mathematician, doesn't make any sense to me. Zero is neither positive or negative. This only in Python, it only holds for floating point numbers.
Okay.
Because the way floating point numbers are represented in Python and most other programming languages is that there is one bit that kind of holds the sign of the number, and then there's some bits that kind of hold the magnitude, and some that kind of holds more the precision part, the mantissa, I guess it's called. This means that you can have a number that's zero, and then you can kind of flip the bit on whether it's a plus or minus for zero. So while Python knows that negative zero and positive zero are the same numbers, it kind of bleeds through a little bit, mainly when you're displaying things using f strings. I guess is kind of what we're at least dealing with in this small little update.
Yeah,
and it's really a tiny thing, but it got its own PEP, which was kind of interesting. So they did a full PEP 682 to kind of talk about how we want to add a small extension to this format mini language that you can use for f strings and also for string.format, where you kind of have your variable and then you do a colon. And for instance, for floating point numbers, you can then do a number that specifies how many characters you want to use for the full number, a dot, and then how many, another digit that kind of tells you how many digits you want to display after the decimal point. And if you would do something like a small negative number, so say minus 0.00 something, and then show this as an f string where you just show one or two numbers after the decimal point, it will show up as negative 0.00.
Which seems weird.
Yeah, it will just look weird, right?
Yeah.
Even though it originally was negative, so there might be some interesting information there. But typically when you're displaying this, you just want to show that this is zero. So what they have added is that you can then add in a small z that will then remove the sign for zeros. So it's extremely pointed at this one little thing that's sometimes happens. But it's a fun little feature that now makes zeros be just plain zeros and not negative zeros. So,
okay, simple display change there to kind of fix stuff up.
Yep.
Yeah.
Yeah, it's the negative zero part is actually part of the IEEE standard. So anybody who implements the floating point standard supports minus zeros. So you can blame the engineers there, Mr. Mathematician. So.
Over-engineered.
Exactly. Yeah. It's a historical thing of we needed a bit for positive or negative, and as a consequence of that, some moron can turn it on when it's zero. Yes. Yeah.
One of the things that I think we've discussed it on the show was some of the proposals for looking at how long. I think Garana mentioned it earlier. Python's been around 30 years, and so lots of standards have kind of come and gone, and there's lots of stuff sort of hiding inside the standard library. And
Yep.
there's this term that people have been throwing around, this idea of dead batteries. That stuff that, how much is this being used? How much is it looked at? And another stat I think that was run before was like, how often has anybody touched this code? So they're looking at some of the ways of removing some of the dead batteries, at least, in upcoming versions. Are there ones that are being removed directly in this version?
No, it's all deprecation here.
Deprecation.
It's all heading as part of the move forward. And like you're saying, right? Code's painful. The more you have, the more you've got to maintain.
Yeah.
My most productive coding days generally are when I'm deleting more code than when I'm writing.
Right.
And as you mentioned, so PEP 594 has been kicking around for a while. There's been a few effects on it in earlier versions, but most of it kicked in 3.11. And essentially, it's almost a couple dozen modules have been marked as deprecated, and they'll be fully removed 2 versions from now in 3.13. And we'll link to the PEP if you want to see the full list. But honestly, there's nothing here unless you're maintaining really old code that you're ever going to miss. Most of it's outdated stuff like Telnet or some old audio file formats that our younger listeners will have never even heard of. And there's other things that, although there's still use for them, they've been replaced. So the crypt module has been kicking around for a while. You shouldn't be using it. It's out of date. And you should be using hashlib for most of it and the things that hashlib doesn't cover. The third-party cryptography module should be used instead. So essentially, we're just trying to clean up the code, stuff that the core people don't want to maintain because there's effort in that. And this is the way things should be. Make it easier on all those people who are volunteering their time to keep our code happy.
Yeah, and we'll include a link to PEP 594, and then there's like a list of the actual deprecated modules that you should be looking at. Again, most of them were a bit of head scratchers of like, oh, that's interesting that even got added. Seemed kind of very specific, especially some of those audio formats. So that leads us to the final question that we have every year. At this point in your life, should you think about upgrading to Python 3.11? And I know the answer is always sort of it depends, but are there some specific determining factors this year that you feel pushes you one way or another? Garana, do you want to start?
Sure. Yeah, I think that the biggest features this time are things that just make your life better as a developer.
Yeah.
So I've already talked about the tracebacks, which I really enjoy, and then just the speed up, things running faster, which also is really nice. So I think I would kind of start using 3.11 at least just as my personal interpreter as soon as possible, really. And I am already kind of just using the release candidates, and they've been working very well for me. So I think in that sense, if you're kind of just stuff that, nothing will kind of, it won't have big consequences if stuff for some reason won't work. Definitely just jump over to 3.11 as fast as you can, I think. And one thing that has been nice this time around is that several of the bigger, at least data science libraries, have already produced wheels for Python 3.11.
Oh, great.
Now, way before the actual release. So one thing that's been holding me back a little bit on earlier releases is that it's taken a while before libraries like NumPy, SciPy, and so on have gotten their wheels out. So that means that it's just been hard to deploy my data science stuff on the new version. But this time around, they've been really early. So even getting the third-party packages will mostly work. So I'm feeling quite good about being able to upgrade early to 3.11.
I'm wondering about that. Mark Shannon at PyCon had kind of a lightning talk. I think it was even that he's like, please test 3.11. And, I know Pablo's been saying the same thing, and a lot of people kind of pushing that.
Yeah.
So I wonder if that's some of the fire that's under people to make the new versions, or if it's kind of a double-edged thing where they're excited about some of the changes in the new version.
Right. Yeah, I guess it might be an effect of both. And I'll definitely also say that if you kind of have the stuff that's kind of running your business, be careful before upgrading, kind of, and make sure you have proper tests and kind of all those things in place. And maybe more so than for a long time, they've done a lot of changes to the internals of Python.
Big changes,
So,
yeah.
so there might be some weird edge cases that for some reason we haven't been able to find during the testing periods. But they've done a fantastic job on rooting out most of it, I think. So I think it's still fairly safe, but don't kind of bet your business on just throwing 3.11 in there.
Yeah, don't blindly step into it.
Right.
Yeah.
And I mean, that's the truism for any new version, right? It's nothing particular about this one. So
yeah. So what do you think, Christopher?
Yeah, to echo a little bit of what he said, my favorite thing out of 3.10 was the error messages, right? Like it's the thing that really impacted my day to day. Everything else I don't know, I don't really see as I go along, and a lot of it always, we talk about this every year. A lot of it depends on who and why you're writing your code. So if you're a library maintainer, you are not going to take on exception groups anytime soon, because as soon as you do, you have to put in code that says, and if they're not using 3.11, do this other thing instead. Yeah. So I still don't use the walrus operator because I'm supporting things before those libraries, right? So it just hasn't become part of my code. Whereas something like the error messages, it only impacts me as the developer. It doesn't, it's the environment I'm developing in. And so it makes a big difference for me and doesn't touch the libraries. If you're writing code that's more, so a lot of my clients, I'm writing a website in Django, then I don't have to worry about the library maintaining. I'm shipping to a version on their web server, and then it doesn't matter. I can write and take advantage of whatever I want to take advantage of, right? So a lot of it is who's your target. Yeah. And, like he said, test. And,
yeah.
And that, honestly, that goes not just for major point increases, but for minor point increases as well, right? You should never touch anything. Don't change anything without running tests. So, if I were Google, would I put it on every one of my servers yet? No. For a lot of my clients, will it make any difference? Yeah. If it's faster, fantastic, right? So do a little bit of testing and roll the dice.
Cool. Well, Garana and Christopher, I really want to thank you for coming on the show again. It's been fun to do these every year for the last couple of years here at Real Python. And I'm excited to see, we're already hinting at stuff and talking about things for 3.12 and 3.13. So it's going to be exciting. So talk to you again in another year.
Yeah, I love this transition. Thank you so much for having me.
Yeah, you're welcome.
Great to talk about it.
All right. Thanks again. And don't forget, DeepGram is the preferred speech-to-text API of Python developers. Get accurate transcripts from any audio with features for understanding. Try it by transcribing 200 hours free at deepgram.com/realpython. I want to thank Garana Hjelle and Christopher Trudeau for coming on the show again. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.